Alright, the next section is involving amino acid metabolism. So in this section, we're going to be dealing with a lot of material. Okay, there's a lot of very important board material in this particular section. So let's go ahead and get rolling. The first thing we're going to do is overview the concept of amino acid degradation. Okay, there's a few common themes that you should think about before we go into further detail. So let's take a look here. With amino acid degradation, the idea is that you have proteins, and proteins, of course, are going to be degraded to individual amino acids. Now, in order to degrade proteins into amino acids, you have to break a special type of bond. Okay, what was that bond? That's a peptide bond. A peptide bond is basically an amide linkage that holds the amino acids together. And there's going to be enzymes that are called proteases that are going to do the job of breaking these peptide bonds. So, once the proteases can break the proteins into individual amino acids, basically all an amino acid is a carbon skeleton that's linked to an amino group. Okay, so amino acids, I want you to think of them as having a carbon skeleton linked to an amino group. How are and these are going to be dealt with separately. Okay, so the carbon skeletons are going to be utilized either for energy, to generate energy, or they're going to be utilized to synthesize other compounds. And we'll be spending a great deal of time in this section talking about those other compounds that the carbon skeletons of proteins can be used for. Now, the amino group that breaks off of the amino acid ends up turning into ammonia. Okay, it turns into ammonia or ammonium being NH4+, the form that would usually predominate. But the point is that ammonia is toxic. It's a molecule that's very toxic to the cell. So the body has to get rid of it. Okay, so the body has a way of getting rid of its nitrogen waste products. And of course that's going to be, it's going to be through the urea cycle. The ammonia is either going to be excreted through the urea cycle, or it's going to be excreted as it is in the kidney. Most ammonia, though, is going to end up being converted to urea through the urea cycle and be excreted that way. But some free ammonia can be released from the kidney. So that's the overview. Okay, that's the overview of amino acid degradation. Think of protein being broken down to amino acids. The amino acids are composed of a carbon skeleton and an amino group. The carbon skeletons are going to be used for energy, perhaps in a fasting state, or in a fed state, they're going to be used to synthesize other compounds, other nitrogen-containing compounds. The ammonia that's released from the amino acid, that's going to be excreted in the urea cycle. Okay, it's going to be used to make urea and excreted, collected in the kidneys, excreted in the urine, or the free ammonia itself can be excreted in the urine as well. All right, let's overview protein digestion in the same way that we did for carbohydrates. Okay, in the same way that we did for carbohydrates. Let's assume that for breakfast in the morning we ate a steak, and then we had some chicken, and then maybe we had some beans, protein rich, and we just filled ourselves with protein. Eat a lot of egg whites, okay? Drank some egg white shake. Well, the point is that you've eaten a lot of protein. Now, how is the protein going to be degraded? It's going to be degraded in a different way than the carbohydrates were. If you remember back to carbohydrates, their degradation begins almost immediately by salivary amylase in the mouth. The proteins, not much is going to happen to them. They're going to pass through the mouth, down the esophagus, and once they reach the stomach, okay, the low pH of the stomach is going to activate pepsinogen into pepsin. And that's going to basically take a big protein and start chopping it up into smaller usable fragments. Okay, into usable fragments. Don't forget your cell biology here. What cell type within the stomach is responsible for secreting hydrochloric acid? Okay, it's the parietal cell. Okay, it's looking at our slide here, it's the parietal cell. The parietal cell is going to be responsible for secreting the acid that lowers the pH of the stomach. Do you remember which cell within the stomach secretes the pepsinogen?